Welcome to this explainer. Today we're tackling a massive cosmic riddle. Literally massive. It's a mathematical paradox about the sheer, mind-boggling size of our universe. It pits the universe's exact age directly against its physical dimensions. And let me tell you, once you wrap your head around the solution, it's going to completely change how you view space, time, and reality itself.
So here's the core paradox. If someone tells you the universe is 13.8 billion years old, logic naturally screams that it can't possibly be bigger than 13.8 billion light years across, right? After all, the golden rule of physics is that absolutely nothing travels faster than light. If you're confused right now, you are completely justified. If light has only had exactly 13.8 billion years to travel since the literal dawn of time, how in the cosmos could our observable universe measure a jaw-dropping 93 billion light years across?
Okay, let's dive into this. The universe we see is almost 7 times larger than what simple, straightforward math suggests it should be. It honestly feels like a massive calculation error, or like someone is secretly breaking the laws of physics behind our backs. But trust me, the math works out perfectly. To truly grasp how this happens, though, we need to unlearn a few assumed concepts first. Section 1. 3 big cosmic misconceptions.
First up, it's incredibly easy to fall into the trap of thinking a light year is a measure of time. I mean, it sounds like time, right? But it's actually a strict measure of distance, about 9.46 trillion kilometers. It geometrically anchors us. When astrophysicists say a star is 1 light year away, they mean it takes exactly 1 Earth year for that star's light to physically cross that vast distance and hit our telescopes. Mentally locking in this geometric distinction is the absolute first step to solving our mystery.
Misconception number 2 is all about the Big Bang itself. You know that classic, familiar image of a fiery explosion happening inside some pre-existing dark, empty void? Yeah, it's time to completely scrub that from your mind. There was absolutely no empty space waiting to be filled. There was no theoretical outside to explode into. The Big Bang wasn't an explosion in space, it was an explosion of space. Everything, all space, time, and energy, was infinitely compressed into a dense singularity. Then, the very fabric of space itself began to violently stretch. That metric expansion essentially created the dimension of space as it expanded outward, and it fundamentally hasn't stopped stretching since that very first fraction of a second.
And finally, misconception 3 is about our ultimate cosmic speed limit. Albert Einstein taught us that nothing with mass can travel through space faster than the speed of light, which clocks in at a blistering 300,000 kilometers per second. This absolute hard limit brings us crashing right back into our paradox. If nothing moves faster than this, how did the universe get so incredibly huge in such a relatively short window of cosmic time?
Section 2. Space itself is expanding. Here is the missing key to this whole thing. Einstein's famous speed limit strictly applies to objects moving through space. A rocket, a planet, even a photon of light, none of them can ever break that 300,000 kilometers per second barrier. But, and this is a massive but, that speed limit absolutely does not apply to the fabric of space itself. There is literally no law of physics anywhere that restricts how fast space can stretch and grow. This isn't just some convenient mathematical loophole, it's a foundational feature of general relativity.
And this brilliantly illustrates how it actually works in practice. Picture a tiny ant walking across a rubber band. The ant has a maximum walking speed, right? That represents our absolute speed of light. Now, imagine that as the ant walks, someone is pulling and continuously stretching that rubber band. The physical distance between the ant and its destination keeps increasing, even as the ant furiously marches forward. If you swap out the ant for a particle of light, and the rubber band for the foundational fabric of space, you've got the exact reality of our universe for the last 13.8 billion years. Light is steadily traveling forward, but the space beneath it is continuously, relentlessly stretching out.
Section 3. Solving the 93 billion paradox.
Let's look at the absolute oldest light in the universe, a relic known as the cosmic microwave background. This light dates back to the very moment the early universe finally cooled down enough for photons to actually travel freely without instantly smashing into dense matter. When this ancient light was first emitted, the specific region of space it came from was actually pretty close to where Earth would eventually form billions of years later. We're talking only about 42 million light-years away. So the light set off on its journey toward us from that relatively short, manageable distance.
But remember our stretching rubber band? While that ancient light traveled toward us for a staggering 13.8 billion years, the fabric of space was constantly expanding, every single second. With every second of that epic journey, space stretched. This means the original source of that light was being steadily carried further and further away from us. By the time that exact light finally reached our modern telescopes today, relentless cosmic expansion had pushed its starting point an astonishing 46 billion light-years away in every direction.
So the crucial point is, the math is actually quite simple from here. The absolute furthest light we can see in any direction has been stretched out to a radius of roughly 46 billion light-years. Double that radius to get the full width of what we can see side to side, and boom, you get a staggering diameter of 93 billion light-years. The universe is 93 billion light-years wide not because anything broke the speed of light, but because space itself fundamentally expanded while the light was in transit. The light played by all the rules. Space just didn't stay still.
Section 4. The Fading Observable Universe.
You see, that 93 billion figure doesn't actually describe the entire universe. It exclusively describes the observable universe. Imagine standing in the middle of a vast, foggy field at night with a flashlight. You can only see the things directly illuminated within your flashlight's beam. Beyond that radius, the field keeps going on indefinitely, but your light just hasn't reached it. Our 93 billion light-year diameter is simply our cosmic flashlight radius. It's a sphere centered entirely on us, the observer, making it a relative boundary, not a physical edge. Beyond it, the unobservable universe likely continues on infinitely.
And here is where things get truly wild. The universe is dominated by something entirely invisible to us. A massive 68% of the cosmos is made up of a mysterious, undetectable force called dark energy. We honestly don't know exactly what it is, but we know exactly what it does. Dark energy is causing the expansion of the universe to actively accelerate. Space isn't just stretching at a constant, steady rate. It's stretching faster and faster with every passing second.
Because of this accelerating expansion driven by dark energy, we're facing a deeply melancholic reality about the future of the cosmos. Our observable universe is effectively shrinking over time. Galaxies that are currently hovering right at the very edge of our vision are being pushed away by the expansion of space so incredibly fast that, very soon, the space between us and them will be stretching much faster than the speed of light. The light from those distant galaxies will never be able to bridge that rapidly growing gap. One by one, they will quietly slip out of our observable universe, fading into the dark forever.
Which leaves us with a final, haunting question. Billions of years from now, as cosmic expansion permanently isolates our local galactic neighborhood from the rest of the cosmos, will future civilizations simply look up into a completely empty, pitch-black night sky? They might never even know about the 93 billion light-year vastness that we are privileged enough to witness today. It really makes you realize just how incredibly lucky we are to be looking up at the exact right moment in cosmic history. Keep wondering, and I'll see you in the next explainer.